Welcome to the second video in our series on the carbon-neutral steel building system, sponsored by the Canadian Sheet Steel Building Institute. In the first video, we introduced the CN-SBI and discussed the objectives of the CN-SBS project. In this video, we're going to talk about the results of Phase 1. We're here at the University of Waterloo School of Architecture, located in Cambridge, Ontario. We're fortunate to be working with Professor Terry Meyerboak, who was involved with Phase 1 of this CN-SBS project. Terry, thanks for being with us. Can you give us a brief background of your area of research and what you do here at the university?
I've been teaching here full-time since 1986. I started off in my first part of my teaching in building construction, coming out of a background of teaching in structural design and helping out with that part of the curriculum. During the 1990s, when the sustainability movement was really gaining ground and I was trying to become a tenured professor, I decided that that should be another very important area of my research. And so since the mid-90s to the present, I've been really combining studies in building construction, studies in structural steel, which is a very pet area of mine, as well as in growing studies in carbon neutral design, trying to combine them all together into my teaching and my research.
Let's talk a little bit about carbon neutrality, and there's various classification systems for sustainable construction. Can you just kind of list for us and identify the key ones?
Well, I think one of the things that's driving most of the nomenclature right now is a preference to look at reducing our greenhouse gas emissions, because that's what's driving global warming, and that's the big question right now. So if you look at the overall issue with buildings, account for around 40% of greenhouse gas emissions on average. That's just the buildings. If we start to think about where buildings are located, whether it's an urban building or a suburban building, the transportation to and from the building, you can begin to inch that up to maybe 70% of greenhouse gas emissions from buildings and their environments. And so that is all really driven by operating energy. Operating energy would be the amount of greenhouse gas emissions that come from burning fossil fuels in order to heat, cool, and light the buildings. And the reason that we look sort of first at operating energy is that it's the biggest offender. If you look at the whole picture of greenhouse gas emissions, about 80% of the problem is operating energy, and about 20% of the problem is what we call embodied energy. So if we're looking more holistically at carbon neutral design is trying to make people stop using fossil fuels, stop burning fossil fuels, so that we can get a situation where by redesigning the building to reduce operating energy, to eliminate our dependence on fossil fuels, to increase our use of renewable energy such as photovoltaics, wind, and other sort of more friendly, non-fossil fuel dependent systems, we can come into a holistic balance so that we have eventually no greenhouse gas emissions from a carbon neutral building. If we start to look at operating energy versus embodied energy, this is where we begin to get into this project and what the findings of this project are really about. Embodied energy only accounts for about 20% of greenhouse gas emissions associated with buildings. And so embodied energy is the energy it requires to extract materials, to manufacture materials, to transport them to the site. So it's kept in the materials. It also includes the energy to renew those materials once they're in the building.
The CN-SBS project is focusing on a retail building. Now, retail buildings, what challenges do they pose as a type of building for sustainable construction?
I think we're going to see a lot of change in retail over the years. We have seen a surge in the creation of small retail buildings in the last 20 years that's really unprecedented in terms of building. I think retail will change in terms of the global awareness of the cost of goods that are coming from offshore, the environmental costs of those, the way that they're manufactured. So retail is going to change, and if we have a use that's going to change, then the building that it's in has to be able to adapt. So the idea then with retail is that we have the ability, as we can perfect systems of daylighting and passive systems, or if the Shoppers Drug Mart isn't there anymore and it wants to be some other kind of store, that there's an adaptability that's really built in the structural system. And I think we've seen this with these kind of systems over the years, whereas if we have a column and beam or a frame type system, we have the ability to change everything else around it while it remains. Whereas if we have a very heavy load-bearing system, there's very little flexibility in terms of a change of use that may require access to light or natural ventilation that just isn't there in the existing structure.
So phase one of the CN-SBS project, our objective from the CSSBI's point of view was to start the process of developing conceptually a retail building that was carbon neutral, that incorporated a steel building system. That was what our objective was. And if you could just summarize the conclusions of that, of the study in general, the conclusions of phase one.
The conclusions, I think, more or less pointed out the adaptability of the steel system and how well it worked with the retail typology, the 600 square meter retail building, which was the subject of the study. The project itself was interesting because it did begin to address the need, when you're analyzing a project like this, to separate operating energy and embodied energy. Because one of the challenges with a retail building as a building type, with a retail building, a lot of retailers don't want daylight in their building because it might fade the product. So trying to prevent the same light coming in that can give you the ability to turn the electric lights off to provide free heat is difficult in a retail type. So there were issues with the design of the building, with orientation, trying to make sure that the sunlight didn't penetrate and fade all the product. And then the idea of natural ventilation. There are certain regional locations where that's not going to work well. I mean, this study was done in Cambridge, Ontario, which is a cold climate. So it had certain aspects of climate that were factored in. But again, if you're looking at security, operable windows that might need to be left open at night in order to evacuate the heat out of a building and let the cool night air in to cool things down, that was difficult. So I think those sorts of facts that surfaced during the study were difficult to deal with the retail typology. So looking at the scale of the building, the height of the building, the amount of roof area, if we're going to be putting photovoltaic systems on the building, trying to look at the shape of the building to best suit the slope of the PV so that it's at an optimal angle for the sun. That had to inflect the shape of the structure of the building as well. So trying to make the building shape and form and height and volume optimal in order to be able to maximize the renewables and bring a certain amount of light in, so that the study was quite complex in those elements.
The CN-SBS project is originally envisioned as a carbon neutral building system, and down the road that it may become that, but practically it's going to be a net zero building system as the first step to control operating energy, as opposed to a holistic carbon neutral building.
And that's where things are working very positively these days, and I think it's worth pushing in that direction now, because I think it's attainable. I mean, we know it's attainable. There are buildings out there that do manage to go net zero. Trying to get those systems perfected and into mass, not as mass production, but mass adoption, I think is very important. And to be able to actually construct one of these and test it is really exciting.
Thank you, Terry, for helping us with this video. Make sure you check the CSSBI website for future videos on the CN-SBS project.